Hey everyone, Mr. Kimsing here, and today I want to talk about this concept of variance and standard deviation. So up until this point, we've been talking about this idea of measures of spread, right? And we want to know how far things are from each other within the same data set. So we've been using stuff like the range or the interquartile range, each time we introduce a new type, they're basically trying to build upon each other, right? So the range only uses two values. The interquartile range tries to split that up. It's dividing up into four groups. But the idea is no matter how many kind of groups or things you're going to try and incorporate, basically there's going to be some level of inaccuracy in determining how spread apart everything is unless you use like every single value. And that's basically what these measures do, right? They're considering every single value in the data set, and the variance and standard deviation are two of the ways that we do that. They each play their own role, so I want to talk about that in this lesson. So the symbol that we use to represent these, we use this little guy here. It's like a lowercase sigma. You may have seen that with the sum, that's the uppercase one, but this is like the lowercase guy. And standard deviation gets this symbol, so they're special, right? The variance, they're referred to as sigma squared, and there is a reason why we square it. Probably said that for another video, but for now I want to talk about this formula, because this formula initially looks really big, bad, and scary, and it's like, what's going on here, right? Basically, we can break this down into three kind of things. I said that we want to consider every single value in the data set, right? And the way that we do that is we compare it to the mean, okay? So when I look at this definition, what it's saying is, okay, let's take the sum, that's for the capital sigma, I'll write sigma again, but yeah, it's the sum. That might be a bit confusing if I write sigma again. So it's the sum of x minus x bar. So x is a score I'm interested in, and x bar is the average or the mean. Okay, so I take x minus the average, so one of the scores minus the average, and then I square that, and then I'm going to add all of those together. I'm going to do that for all the scores that's in the data set, and basically taking the average again of all those numbers there, okay? And so this is the way that we are going to determine the measure of spread. This gives us the variance, right? That's sigma squared. If I wanted the standard deviation, I'll take the square root of the whole thing, right? So the formula for the standard deviation is actually sigma is equal to the square root of that whole thing there. Right. And so basically these formulas are a way that we can determine a much more accurate measure of spread. Although I've tried to break it down and help you interpret what that means, as you can imagine, there is a lot of calculation involved with that. So we typically don't do it in this way to actually calculate it. But I think it is very important that we have a good intuition of what's actually going on here, right? And similar to the other measures of spread, right, when we had a really big range, a really high standard deviation is going to result, or is actually going to imply that there's a really high spread of the values that we have. Okay, so the same kind of idea. I want to talk about this intuition because typically what they'll do in exam questions, they like to throw in a standard deviation question, but then what they'll do is they'll also give a question which tests your understanding a bit more, right? And I'll show you some of those in this lesson and future lessons as well. But let me try and explain the intuition with this cute little diagram here. This is from Maths is Fun. And so let's suppose we've got a situation where this green line here, that represents the average. It's 394 millimeters, the average height of these dogs. And so remember how I said the first thing that we do is we take the scores and we take away the average, right? So the average is 394. And so that's what they've done here. So you can see like this guy here is 206. He's 206 above the mean or the average. This guy's 76 above. This guy's 224 below. This guy's 36 above, looks like. And this guy's 94 below, okay? So that's like the first thing that they take the difference. And that's typically what they'll do is they'll arrange it in like a table like this. So all these numbers, that would just go into this kind of table over here. So we can fill that out if we want. So 206, 76, 36, 94, and 224, okay? And then what we would do is once we've taken the difference there, we're going to square it, okay? So that's this second or third row over here. We're going to square these values, and that's the calculation they've done here. So we've got 206 squared, 76 squared, 36 squared, 94 squared, or the difference actually technically is negative, hey? So negative 94 all squared and negative 224 all squared. Obviously, when you square, that's not going to affect the result though. And you can see now they're going to take the average of all of these numbers. So they're going to treat all of these now as a kind of new data set. They're going to divide by 5 because that's how many numbers there are. And then they're going to get this big old number here. 21,704. Okay, that's a pretty big number. But then to find the standard deviation, we're going to take the square root of that. And the square root is 147. Now, what's good about the square root is you notice how it says to the nearest right? So that's kind of a really key factor about the standard deviation. It's actually in the same kind of units as the original thing. That's why we actually like to use the standard deviation a lot more, because it's kind of respecting the original units of this situation that we have. The variance does have its places as well, but yeah, we'll talk about that at a separate time. Okay, so that's the kind of intuition behind it.